Section 6-7 deals with inverse relations and functions. We need to remember inverse operations are operations that undo each other. Addition undoes subtraction, multiplication undoes division, and the inverse of cubing something is taking the cube root. So if two functions are inverses, they consist of inverse operations performed in the opposite order. So one thing we want to understand is that inverse functions are reflections of each other over the line y equals x. This blue line here is the line y equals x, and the red line is the graph of the function. We have what is the inverse of the relation described by f of x equals 2x minus 1. So 2x minus 1, we graph minus 1 on the y-axis for the y-intercept. We go up 2 and over 1. So this red line is the line y equals 2x minus 1. Now we want to find the inverse. To find the inverse of a function, first thing we do to make it easier is we rewrite that f of x as y equals. We remember when we write something as f of x equals, it's the same as saying y equals 2x minus 1. So to find inverse functions, if you were plotting points, all you would do is switch the x and the y. That makes it a reflection over the line y equals x. So if you're given a set of data points and you're asked to find the inverse, all you need to do are switch the x and the y values. So if I want to find the inverse of this function, I start by switching the x and the y. X equals 2y minus 1, and then I solve for the new y. So I'm going to take x equals 2y minus 1. I'm going to add 1 to each side. I now have x plus 1 equals 2y, and I'm solving for that new y, so now I divide by 2, divide everything by 2. So what we have is x over 2 plus 1 over 2 equals y, because the 2's here cancel. And that new y is our f inverse. And the notation for f inverse is f to the negative 1 of x. That's called the inverse of f. And we could write that as 1/2 x plus 1/2. Now if I graph that, we should be able to see that it is a reflection of the original line over the line y equals x. So I'll graph it in black so it looks different. And we will have a point, I guess we'll do it in green for our point. We'll have a point at the y-intercept, which is 1/2, so that'll be right here. And from that point we go up 1, so that would be 2 here, and over 2, 1, 2. And now we'll draw a line through those 2 points. We'll do it in black so we can see it. Best we can. And there is our graph of the inverse function. Notice, if drawn accurately, we should be able to fold on the blue line, y equals x, and the two inverses will overlap each other. Okay, so you can always check to see if two functions are inverses by graphing them and graphing the line y equals x and seeing if the line y equals x is the reflection line. Now, let's remind ourselves, if we're given a set of points, so let's say we're given this table of values. Okay, so let's say we are given this table of values where the x values are 1, 3, 5, and 9. The y values are 2, negative 3, 4, and 8. To find the inverse of that given relation, our y's will become our x's and our x's will become our y's. So we would have 2, negative 3, 4, and 8. And our y values in the inverse function would be 1, 3, 5, and 9. Simple as that. And then if you're asked to plot the original relation, you just plot these points, 1, 2, 3, negative 3, 5, 4, and 9, 8. And then to plot the inverse, you just plot these points, 2, 1, negative 3, 3, 4, 5, and 8, 9. All right, so let's say we were asked to find the inverse of this function. Ooh. All right, so all we need to do is first switch the x and the y, and then solve for the new y. And the reason that's the inverse is defined to be the reflection over the line y equals x. And to reflect over the line y equals x, you just switch the x and the y. So here we would get x equals 3y cubed plus 2, and we want to solve for that new y. So we would subtract 2 from each side. X minus 2 equals 3y cubed. We would divide by 3. On the left, divide everything by 3. So now we have x over 3 minus 2 over 3, these 3's canceled, equals y cubed. And to undo a cube, we take the cube root. So at this point, we would take the cube root of each side. And we would get y equals the cube root of x over 3 minus 2 over 3. And once you find the inverse, if the original was given as y equals, the inverse should be written as y to the negative 1. That means y inverse equals the cube root of x over 3 minus 2 over 3. So that's how we find the inverse of a given function. Switch the x and the y, and solve for the new y. All right, so let's try another one. Find the inverse. So again, switch the x and the y. So I have x equals y minus 1 all over 2, and I want to solve for that new y. So to do that, we'll clear the fraction first. We'll multiply both sides by 2. That gives us a cancel here. I now have 2x equals y minus 1. We're solving for that new y, so we want to get that by itself. So we add 1. 2x plus 1 equals y. So we have found the inverse, and now we write it with proper notation. Y inverse equals 2x plus 1. Okay. So again, here we can see, we're going to look at the graphs of inverses. So examine the graphs of f of x equals root x minus 2, that's this one. And f inverse of x, remember that's the notation for the inverse of f, is x squared plus 2. That's that graph. And the green line is the line y equals x. So if I folded on that green line, you would see that these two functions would overlap each other. All right, so now we want to take a look at the relationship between the domain and range of inverses. So we have f of x, and we have f inverse of x. I want to look at the domain of f of x and the range of f of x. And then I want to look at the domain of f inverse and the range of f inverse. So the domain of f, we remember domain are all the acceptable x values for the function. So we can see this function right here has no x values less than 2. So the domain would be x equals all real numbers such that x is greater than or equal to 2. And if I look at the domain of f inverse, well, the domain, remember, is the x values. So if we're looking at f inverse, the x values start at x equals 0, and that's an arrow at the end, so they continue on forever. So the domain for f inverse would be x equals all real numbers such that x is greater than or equal to 0. Now let's look at the range for f of x. The range are the y values. So here, the y values start at 0, and it's got an arrow up here, so this would continue to go upwards forever. So the range would be y equals all real numbers, such that y is greater than or equal to 0. And then if we look at the range for f inverse, the first y value we have is 2, and it goes up forever. So the range would be y equals all real numbers, such that y is greater than or equal to 2. So if we look carefully here, we can see the domain values for f of x written in terms of x are the same as the range values of f inverse. Because we remember, to make an inverse, we switch the x and the y. And the domain for f inverse, which we'll highlight here in red, x is greater than or equal to 0, is the same as the range of f, but in terms of y. Y is greater than or equal to 0. So if I give you the domain of f and the range of f, you should be able to tell me the domain and range of f inverse, because the domain of f inverse should be the same as the range of f, and the range of f inverse should be the same as the domain of f. So looking at this, we have find the domain and range of the inverse function. So the original function is x minus 6 squared. Well, we know how to graph that because it's just a shifted parabola. It's shifted right 6. And the 0 is at 6, 0. So it's a parabola that opens up like this. So it looks like that. So the domain of the original. Well, parabolas, this x value, there are no x values that will not work in the function x minus 6 squared. So the domain would be x equals all real numbers. And the range of the original, the first y value is at 0, and they go upwards from there. So the range would be y equals all real numbers, such that y is greater than or equal to 0. So now I should be able to, from that, just determine what the domain and range of the inverse function is. So the domain of the inverse would be the same as the range of the original. So we would say x equals all real numbers such that x is greater than or equal to 0. And the range of the inverse would be the same as the domain of the original. Y equals all real numbers. So they are related in that way. Okay, so we have a worksheet, 6.7 worksheet is your homework, so please use these notes to help you. And the solutions to the homework are on my website under Chapter 6, Homework Solutions.